Hello all, this is Farhana. Welcome to my channel. In this video, I'm going to build a social media application system design. You will see how to create the same architecture using AWS, Microsoft, Azure, and Google Cloud Services. And we'll learn where those services will fit into any architecture. I want to build a simple social media application like a mini version of Instagram, Facebook, or Twitter. And then we will see how to design the same architecture using different services from AWS, Azure, and GCP one by one. Okay, so let's say we are building twitter.com. So let's say our user will access it using this name. So first thing, if you want to deploy this application in your own premises data center, then the first thing you will need is one private network. Like every company has their own private network. We would also require something like this to make it secure, of course. The next thing you would require is a web server. Now to start with, suppose we are starting up, then we will probably build a small code in maybe PHP and we will run in some kind of application server or a web server. And it should work maybe for at least 100 users or lower than that. And it works fine. And our user will access this application using IP address initially. So maybe this VM has some public IP and use access it. Now that what happened over the time is like you want to now extend your application and you want to add some business logic, some UI stuff, the login functionality and more. So that's where you need to then have a web server as well as an application server so that all the front end stuff is taken care by web servers, but all the business logic. Suppose it's a twitter.com kind of application, then maybe you connect with different people. So adding that data and everything is taken care by application server. And of course, further, if you want to extend it, you need some kind of database, like relational database, MySQL, or even you can have Oracle, whatever you prefer, right? So if you have this kind of application, it works well, and it's called 3-tier architecture, and your users are using this application using an IP address, right? So this work well, and considering this app is really doing good, your website is really doing good, and there is more tractions from the users, and somewhere then your web server or an application server becomes a bottleneck. Maybe they're not able to handle the increased load on the application. So what's the solution? Typically, we will scale. Now that scaling can happen, vertical scaling, that means you increase the capacity of these machines, or you could horizontally scaling. So typically in 3-tier architecture, you will see web servers and application servers are scaled horizontally. Horizontally, that means you will bring more web servers and more application servers, right? Like I have shown here. Okay, so that's fine. Now I have multiple web servers and multiple application servers. But as you know, there are multiple web servers. That means there are multiple IP addresses. And now is the time where we need an intelligent entity who can really distribute load to this web server. And that's where we bring in load balancer. Load balancer service. So if you have heard about the load balancer like HA proxy and Nginx, then do something like this. A user hits a request to the load balancer and it eventually distributes that to the backend server like this. And as you know, now we have load balancer also, and your application is really catching up. Typically, you don't want your application to be accessed using IP address. You want people to access your application with the domain name, something called say twitter.com. And that's where you need some DNS servers, where you can map your DNS domain name to load balancer IP address, probably, right? Okay, so far so good. This works fine, right? So now your application is 3-tier and it's working well. Now catching up further, and you're now having lots of data, or say you have number of friends are growing, number of connections are growing, number of posts are growing, and that's where your relational database cannot really serve this kind of data storage. You cannot do that in relational database. For this, you need a scalable database, and also for connection information, it all makes sense to rather going for NoSQL database. So what you will do, bring in NoSQL database like MongoDB or Cassandra, anything that you want to have. So some sort of data is stored in relational database and other is stored in non-relational or NoSQL database. But still your relational database could be a performance bottleneck. Maybe there is read heavy operations happening on this database, and for that typically you will bring in one more component which is called database cache. Okay, so you bring in some database cache engine like Redis or Memcache, where you can query the frequency access data so that your application servers did not hit the database, but all the requests are served from this cache engine. Okay, so this is fairly better architecture than where you started with. Now, next thing, as you know, Twitter might be getting millions of posts and pictures uploaded daily, and the videos daily. So now disks which are attached to the virtual machines are not really capable of extending on the fly. So let's say they have size limitation, and that's where all these media pictures are never stored typically on these web servers or application server. For this, you need some unlimited kind of storage, and that an external storage, and it should not be necessarily a block storage like your disk. It can be a file storage, like a shared file system, or some external storage like Google Drive, if you are aware of that, right? So you need some external storage where you store this information, okay? So that may your that make your storage that solve your storage capacity problem if you use external storage. That's fine. So far so good. Now, next what happens is when you upload a video or photo, you need some kind of content filter. Like maybe you are uploading videos and that video has some content which are objectionable, or there are some pictures having some nudity, let's say. So you need some content filter which can do this on the fly, and then those pictures, videos should be actually stored here in the external storage. So we bring in one more component there, right? Okay. That is fine. You also know Twitter also throws lots of ads, and it's continuously watching what activities you are doing while you are on the Twitter page, or maybe what kind of products you are liking, what kind of posts you are liking, and based on that, it gives you suggestion and the following request will throw a lot of ads, right? So this is called click stream analysis. Every click is getting captured somewhere and it's getting analyzed in real time. So you need some kind of click stream analysis engine. So what all tweets are going on in the market, what are the moods of the people, currently all this is done using the click stream analysis. Now all this data is stored somewhere in the external storage, and you need an external storage for this, like the storage for storing this data. And further you want to take this data and do some operations, like you need to run some maybe aggregation. You need to sort your data and you need to find some meaning out of it. And that's where you need some kind of Hadoop platform. And you would also require over the time one data warehouse. Why? Because maybe at the end of the year, Twitter does a lot of data analytics, right? Maybe at the end of the year, they want to find out which kind of users are accessing Twitter more, what are their age, in which region they come from, how particular features of Twitter is being used, so that they can concentrate more on those kind of features. What is trending, right? So all this information is taken out by storing this information in some kind of data warehouse engine and then doing some kind of business intelligence on top of it. So you need some business intelligence tool which can query this data, analyzing this data, and then there are reports generated out of which then Twitter can take decisions like next year, maybe this is our strategy, or we will focus on this area or that area. So some business decision you can drive based on what analytics result come out of this, okay? So this is more on a back-end side, which end user does not really know, but this is happening there. Okay, so far so good, right? So we have extended our architecture. Now next what you have is all these photos and videos. They can be directly served over the internet, because you consider this like a Google Drive. So you can directly maybe stream your video and watch pictures directly from this storage. So users might come from the web server and they may watch whatever post. Suppose you have posted a video, so they watch that video here, but sometimes your user come from using mobile devices. Nowadays, they will watch your videos through mobile phones, and in that case, you need some video, but in probably different format. That's because mobile devices might play a different format of the video. And for this, typically, we will need some kind of video converter in between. Next, all these photos and videos are typically served from, as I said, from the external storage. But whenever some video gets viral, millions of users watch that video. Now, every time if that video is fetched from this location, this might become a bottleneck, or you may pay a price because your data is flowing out to the internet and there is a lot of data usage for your video. So to solve this problem, you need to have something called CDN, as I'm showing here, Content Delivery Network, which is nothing but which cache these videos and pictures to the nearest caching devices from where the user is accessing your videos, right? So that all the users in that geography, when they want to watch the same video, it is served from here. It is not really served from here. So user experience the low latency and gets better experience. So in application like Instagram and Facebook or YouTube, largely, they would have lots of content delivery network through which the contents are served. Okay, so far so good. We have experience architecture further. Now, Twitter also sends you mobile notification, right? There's a new follow request or there's a likes on your post. Now for this, we need some kind of notification service. Maybe you get a SMS or mobile push notification. So you need that service also. It sends you email, right? For the various activities, you can disable that. But yeah, there's an option to opt for email service as well. And further, you can also chat with your friends. And for this, typically, a queue is used. Now messaging queue. If you heard about like Rabbit MQ or JMS query queues, IBM MQ, these all are query services which enables the kind of first in, first out, and that kind of data structure. So for chatting, maybe you require some kind of queue service as well. Okay, so if we consider all these services, it's a bare minimum kind of social media application. I'm sure there must be many more components, but we are just sticking to this as of now. And finally, if you want to deploy this architecture and monitor it continuously, like how many VMs are doing, how my VMs are doing, how my databases are doing, how my storage is doing, how much storage is there. So for all this, you need some kind of monitoring service and a dashboard like production database where you can monitor health of your application. Okay. So overall, this will be your architecture, and this probably will be deployed on premises. And now let's see if we want to do something on AWS and how we will do this. We want to do this on AWS. So let's see, first thing, this private network, would you see here? It's called virtual private network. So it's not exactly the way it's shown here because some of these services are outside VPC, but I cannot accommodate that in a diagram. But consider VPC as one private isolated network that AWS gives you. And then you would have to manage all the public network for web servers and load balancer, and private network for databases. That is a separate part of discussion. But the VPC is a network service. Now, all these VMs that we are talking about, these are nothing but EC2 machines, right? And the disk that we attach is called EBS, Elastic Block Storage. And they have limitation of maximum size. So EC2 and EBC solve your problem of the VMs that typically will deploy your application on whether web service or app service. Now further, you can have an auto scaling enabled for EC2. That means if the load balancer on these EC2 instances, then you can scale horizontally automatically, and if the load balancer decreases, they can scale down maybe from 2 machines. They can go to up to 10 machines from they can go back to the 2 machine depending on the load that you can configure using auto scaling feature of AWS EC2. Further, for relational database, there is a service called RDS, and NoSQL database, there is a service called DynamoDB. For DB cache, there's a service called Elastic Cache service, and it comes with a Redis and Memcache engine in that. Okay, so further, as you see, there's a load balancer. So in with Amazon, there is a service called ELB, Elastic Load Balancer service, which can distribute the incoming traffic to multiple backend EC2 machines like this. And for that, if you want to have your domain name mapping to your load balancer, then you need a DNS service, which is called Route 53. Okay, great. Now let's talk about the other stuff that we have, like for external storage. It's a S3 service of Amazon Simple Storage service, which is an unlimited storage. You can just go on dumping the data, and it's accessible over the internet directly, and there's no size limitation how much data you can store in your S3 bucket. Also, you need some content filters. So there's a service called Recognition, which can find out an object in the image, and it can filter out before you upload it to, say, S3 bucket. Okay, so now, as I said, you need some kind of services where your video from one format get converted to another format like MP4 to some mobile friendly format. Now for this, one option is to run some EC2 machines which continuously watch your S3 bucket for new videos. As the new video comes, they download it, convert it, and put it back into another bucket. That's one option. But there's a better option, like for this is using Lambda services. And now Lambda is a serverless service of Amazon where you just write a code. In that code, you specify how maybe convert a video, and you can execute this Lambda function whenever there is a new upload happening into your S3. So new video comes, Lambda gets triggered. It will convert your video, and maybe you have put in logic that video in another S3 bucket. So now here there are no servers to manage. Everything is taken care by Lambda function, and this is scaled automatically. Okay, so we have got Lambda there. Now let's talk about this click stream analysis. Now for the click stream analysis, there is a service called Kinesis, which can capture your click stream data, and then you can analyze that data. You can even store that data in S3, and you can do much more with whatever data you capture, right? Now for this Spark Hadoop platform, there is a service called EMR. And what EMR does, like operations like aggregation, sorting, and you can run distinguished job, distributed job, Spark job, Flink job, all this you can run in this managed Hadoop cluster. and also need to do ETL transaction from your DynamoDB table. Like maybe you want to do what all friends are there, friends, friend, what activities they are doing. You want to continuously push new posts on your wall. Now all this is done in real time using clickstream analysis. And at the end of the year, maybe you want all this data to be extracted and converted into different format, data cataloging, and further do some data processing using EMR. So you need this glue service. For doing this extraction, extract, transform, and load operation, ETL operations, right? And then finally, all this data, what you process or what data you have, you can store it in the data warehouse service, which is nothing but Redshift in Amazon. So Redshift is a data warehouse service which can store a petabyte scale of data, and you can perform the analysis on the data. And to perform this analysis and see the results, you need some BI tools, which like there are various BI tools in the market, but in Amazon, you will use Amazon QuickSight. Or you can also use Athena, which is SQL query interface. So you can pull data from S3, perform maybe SQL operation on that, and then all those results can be viewed in QuickSight. You can build some graphs, some charts, and then you can get insight of your data based on that. You will take some business decisions. So it's a BI service from Amazon. Okay. We introduced a lot of AWS services here. Now let's move to this side. Now, as I said, there's a content delivery network which can cache your static content, and for this Amazon there is something called CloudFront. And CloudFront stores or cache your data in edge location. Like I said, these edge locations are across the cities, across 100+ cities across the world. And when you use CloudFront service, all your data from S3 or wherever you store your data, it gets cached in the nearest edge location, from where the user is coming, and the data is always served from that edge location for all the users in that geographic. Okay, so that is CloudFront service. So now let's talk about this side also. As I said, you need to send a message and messages and mobile push notification. In Amazon, there's a service called SNS simple notification service that for that. And if you want to send emails, bulk email, then there's an SES service, simple email service. Now for messaging queue, for chatting application, Amazon has built its own queue service, which is called SQS, simple queue service. And finally, to monitor all this infrastructure, how many EC2 instances are doing, how much is CPU utilization of EC2, how is database is doing, all these can be monitored in real time using service called CloudWatch. Even you can set alarms, like if an average CPU utilization goes beyond, say, this percent, send an email or alert to the administrator, or take some action, do some auto scaling here. All this can be done using this CloudWatch alarm there. Okay, so I think we have completely replaced what we did on premises with all AWS services, and I hope you get some idea about all these basic AWS services. Okay, so next we want to see some more AWS services, and let's see some application services. Now, as you know, that Twitter or any other web services or even Amazon itself, it exposes all their services through API calls, so that different third-party application can integrate with these applications. And for that, they need a REST API service where they can expose all their APIs. So in Amazon, you can have managed API gateway where it takes care of scaling, throttling, everything. So you just write a code for your API. Definition of your API, it can be deployed in API gateway. Also, as the mobile usage is increasing, most of your users, the web users, you need to manage your identities. Like when you develop an application, your users must sign up to your application, right? And that means you need to manage your users pool, their access and everything. And for that, you need some user management service. So in AWS, that service is called Cognito, right? So these are more application services that we can use here. Now let's move on ahead and talk about security services in this architecture. So now, as you know, there is one primary service for managing all access in your AWS, like all your AWS users, what access they have, what services they can use. And even when they say one AWS service like EC2 wants to upload a data to S3, then EC2 needs permission to do that. Now, all these accesses and authentication and authorization is managed using Amazon IAM service, Identity and Access Management. It's one of the most important service for securing your AWS account as well as services. Next, what you can also do is you can encrypt your data, which is stored at various storage locations like EBS, block storage, like a disk attached to the EC2. You can encrypt data, data which is stored in S3, which is stored in EMR, Redshift, queue messaging, database, cache. All this data you can encrypt using Amazon KMS, Key Management Service. So it manages all the encryption key for you. You don't need to have your own secure location where you can store your keys and do the encryption. Further, as you know, this application will be accessed probably over HTTPS, which is SSL enable connection. Because obviously if users are doing some transactions or they don't want to lose their important information, you would secure that communication, and for this you need digital certificate, right? So that certificate you either deploy on load balancer, or you may deploy it on CloudFront, so that your communication is secure. For this, Amazon has a service called ACM, Amazon Certificate Manager. Okay, so next, as you know, we can also have the application firewall. Now these application firewall are called WAF, Web Application Firewall. That take care of any attacks. It can prevent like cross-site scripting, SQL injections, even the DDoS attack which are happening. WAF can protect your application from these attacks, and you will typically deploy it on CloudFront or load balancer or in front of your API gateway that we saw in earlier slide. So that you are safe. And other various ways is to secure VPC, the public and private subnet. Here we're talking about application level firewall, so that WAFs, and if you're going for some kind of compliance, for example, PCI DSS compliance, or say you are going for an HIPAA compliance, so your machines need to be patched properly. They should be free from vulnerabilities, right? Or CVE, as you know, and for that there's a service called AWS Inspector. What it does, it puts an agent inside your machines and it scans your machine for any known vulnerability. And then it will give you reports saying like, all these machines, out of these machines, we found these vulnerabilities, go and fix those. So inspector can give insights about what they're inside your machines, right? So, okay, so these are primarily used security service, and there are more, but I will restrict our discussion only to those services as of now. Next, we want to see some development and DevOps services. Now, as you see this architecture, it has a lot of AWS services and all are connected. So when you want to deploy everything by hand, maybe manually, I would say it will take maybe a couple of days to do this without making any error or detecting the error and fixing it. All this has to be done manually. Then it will take 2 or 3 days probably. But with AWS, it gives you ability to code your infrastructure. That's called infrastructure as a code. So you can have a service like CloudFormation. What it does, it takes kind of a template from you, which is in JSON or YAML format, and it will just create this infrastructure from scratch for you. And that too within maybe 30 minutes, depending on what size you have. But typically I have seen it in like 30 minutes maximum, it will create all these resources for you. It's a very powerful service which can provision your infrastructure from the scratch, right? And now this CloudFormation template will be written by some DevOps people. And at the same time, you would have your developers and a QA where developers are writing code for your product, and maybe QAs are writing QA test cases, automation test cases. Now everybody needs some kind of code repository, like a Git code repository. For that, AWS has a code commit service where they can check in the code. So even this CloudFormation template is nothing but a JSON or YAML code. So these guys, your DevOps guys, will write that as a template CloudFormation service. It will take the template and create this infrastructure. Now, once you have this infrastructure up, you require your actual product to be built, and for that you need code build service. So Amazon code build will take the resource code in whatever language you have written in Java or whatever, and it will build that using some kind of build tool like and or Maven. And also while building, it will do some unit testing, and finally it will produce some artifacts. Now artifacts are like your access or binaries, actually your application executable basically. So the code build will do that, will test it, and then you have to deploy this. That means whatever it produces, you have to put these access and binaries in EC2 machines where your application is actually running. So you will require a deployment, and for this you have a code deploy service, right? So if you know about the DevOps, you heard about the term CI and the CD. So this is your CI pipeline, continuous integration pipeline, or a continuous delivery pipeline, you can say. And if you want to have this automated, like, developers and writing the code, checking it in, it automatically gets built. It automatically tested and automatically deployed into corresponding application servers running EC2. Then you can have code pipeline service, right? So you can completely build your CI platform here using these 3 services. Now, if you want further integrate all these things, which project management tools like maybe a Jira or some bugs tracking tool, what's the speed of your development and all the management tool, now it's called CodeStar. CodeStar service, which are very well integrated with Atlassian, Jira, and other tools. So you have complete SDLC control now if you use these development and the DevOps service. Okay, so I think this is clear now where these development and deployment services are used. So same system design for Twitter can be deployed using Microsoft Azure service. Here I'm using Azure VNet for private network, Azure VMs and magnetic disk. I use Azure Blob Storage in place of S3 bucket. I'm using Azure Redis Cache for Memcache, Azure SQL for relational database, and Azure Cosmos DB in place of DynamoDB. I have replaced Kinesis with Azure Stream Analytics, EMR with Databricks, Glue with Azure Data Factory, QuickSight with Power BI, Redshift with Azure Synapse Analytics, and Edge Location as Content Delivery Network. On the left side, I'm using Azure Event Grid, Communication Service, Storage Queue, and Azure Monitor. Now for GCP services, same system design for Twitter can be deployed using Google Cloud Platform. Here I'm using GCP VPC for private network, Google Compute Engine, and persistent disk. I use Google Storage for file storage. I'm using Google Cloud Memory Store, GCP Cloud SQL for relational database, and Cloud Bigtable in place of Azure Cosmos DB. I'm using Google Cloud Dataflow Kafka for clickstream analysis, Google Cloud Dataflow for ETL, Google Studio or Google Looker for analytics, BigQuery for data warehouse, Dataproc, and Google CDN as content delivery network. On the left side, I'm using Cloud PubSub, Google Messaging, and Google Cloud Monitoring Tool for monitoring dashboard. I was curious what cloud technology is used for Twitter.com. So I asked our friend ChatGPT, and here's the response. Twitter uses a combination of technologies to design and operate its platform, but it primarily uses cloud services provided by Amazon Web Service to host its infrastructure. AWS provides a wide range of services that allow Twitter to easily scale its infrastructure as needed to handle the large amount of traffic and data it receives. Additionally, Twitter uses several other technologies such as Cassandra, distributed database management system, and Kafka, a distributed even streamlined platform for storing and processing data at scale. Thank you for listening.